All right. So okay. All right. So today's topic is linear and quadratic equations in single variables. So linear a linear equation is the simplest type that we've learned how to solve throughout algebra in our experience. And that's just the general form looks something like this. Ax plus b. So all linear equations can be simplified to look something like this. They may not always look like this. You might have to combine like terms, switch some things around. But you can always condense things down into something that looks like this. And so again, linear in the variable x. A and b are just numbers, coefficients. So the solution to this is always x equals negative b over a. First thing you do is you subtract the b over, and then you divide the a over, and you get x equals negative b over a. So pretty simple, straightforward stuff. But the way you know it is a linear equation is the highest power of x is 1. So if it has an x squared or an x cubed, then that is not a linear equation. So linear equation just has x to the 1. And you might see something that looks like let's say we can move some stuff around. So we could have 3x minus 7 or minus 5 equals 7x plus, I don't know, 4. So all we have to do, and this is something that's going to come up a lot, is this idea of forms, is we know that the solution to something that looks like this is always this. It's always negative this number divided by this number. So what we can do, and it's pretty easy in this case, but it's also just good practice, is if we rearrange this thing so that it looks like this thing, then we just say that the answer is that over that. So what I mean by that is we want all of the numbers to be on the same side with a 0 on the other side. So we could pull all of the x's, we could pull everything to the left, in which case this 7x gets subtracted over here, and this 4 gets subtracted over here. So you get 3x minus 7x plus minus 5, and then minus 4. So 3 minus 7 is negative 4x, and negative 5 minus 4 is minus 9. All right. So if we use this form, then we know that the answer to this equation is negative b over a. Well, b in this case is all of this, and a is all of this. So x equals negative 9 over negative 4. So in this case, a negative becomes a positive. So x equals negative 9 over 4. But that's pulling everything over to the left. It's important to know that you could have pulled everything over to the right, and it should give you the same answer, but let's check just to make sure. So if we pull everything over to this side, it becomes 7x minus 3x, and then plus 4, and this is a negative 5. So when we pull it over, it becomes plus 5. 7x minus 3x equals 4x, and 4 plus 5 equals plus 9. So again, x equals negative b, which in this case now is plus 9, so negative 9 over 4. So we get the same answer no matter which side we pull it to. And that's a pretty common theme that pops up, is this idea that it doesn't matter in a lot of cases which side you pull things to. Excuse me. If you have a relationship that says this equals this, then you could also rewrite it the other way around. And this is hopefully how real life is, that good relationships actually go both ways, right? So if you have a good relationship, then you would hope that it goes both ways. All right. So this is the idea behind linear equations. Very, very simple. You basically can just combine like terms to something that looks like this, and then the answer will always be in this form. Okay, so the next thing that comes up is quadratic equations. This is how we do things. We start with the simplest case, and then we build up. So for linear equations, the highest power of x is 1. Then for quadratic equations, is the next most difficult thing. And this is highest power of x is 2. So we know that we're going to have we have the same idea, the simplest form thing. So we know we're going to have something, we're going to have terms that have x squared in them, and then we're going to have terms with x in them, and we're going to have numbers that don't have an x or an x squared in. So the way we label this is A, B, C. All right. So a couple things here. Again, just like with the linear equations, they won't always immediately look like this. But the point is you can combine like terms and make them look like this. And that's usually the best thing to do whenever you're solving these kinds of things, is to put them into a form that is familiar, because it really is all about the way things look when solving this, especially when you're starting out. Is just something that looks different doesn't have to physically be different. Just because it looks different, it might be harder to solve. So one of the first steps is rearranging an equation. That's usually a great place to start. So if we combine all the things with an x squared in them, all the things with a x to the first power in them, and then all the things with no variable, it can look like this. So we've seen this thing before. Sorry, I'm getting a question. All right. So this is one of the things that we talked about previously when it comes to factoring. So once we have it in this form, it's easy to factor, or easier to factor, because we can't always just solve something that looks like this for reasons that we've talked about in the past. So our first attempt, first thing that we like to try and do with this is see if we can factor it. And the way we factor it is into some number times x plus a number and some number times x plus a different number. Okay. So one thing to note real quick is when we factor it, we are specifically, again, we're doing this thing where we're changing its form. This thing equals this thing. So they have the same value, but they're just written differently. And this is where that idea comes in, is that this is very easy to solve. This is not. And that's because the thing in parentheses right here, a number times x to the first power plus a number. And then in this parentheses is a number times x to the first power plus a number. We've actually turned a quadratic into two linear equations, a number times x plus another thing. And we know exactly how to solve that. Once we have it in this form, we know that it's always equal to this thing. Okay? So that's what we do. Once we get it here, we know that we know how to solve this linear equation and this one. So the way we do that is we look at, again, this is what we talked about last time with factoring. So the things that multiply together to give you capital A over here are little a and little b.
Just try to get close to 3. Yeah, because I don't want to stay here and watch TV.
And the things that multiply together to give you C are M and N. And then you have the kind of the difficult one. This is with the cross terms.
I mean, you going to sleep, so you might have to cut it out.
So, all right. We have, like I said, they're cross terms. So it's what happens when you cross things in here with things in here. So you have A and N and M and B. All right. So this is the general form. Like I've said before, there are kind of simplified little things to make things a little bit easier, but that's if you like to try and memorize a bunch of different cases, then that might be the way to go. But if you want one, big guaranteed process that works on all of them, then this is your bet. So let's do an example. So let's take a very easy one. 6x squared plus 3x equals 0. All right. So we can do our long drawn out process. If, like I said, if that's what you like to do, it'll work every time, but there are some shortcuts. So A is the number that's in front of x squared. In this case, 6. B is the number that's in front of x. So in this case, it's 3. And C is the number that doesn't have an x or an x squared. And you might say to yourself, well, there isn't one. There's an x squared thing, there's an x thing, but there's nothing else there. And you'd be right. So that makes it 0, because there isn't one of those things. So A times B, AN plus BM, and N times M. So the first thing that we can see is right here. This is the easiest one to solve. 0 equals N times M. It means N or M is 0. We don't know which one, but one of them is definitely 0. And you can kind of just pick one, because then we can just say, well, then the other one is the not 0 one. So we'll just say that M equals 0. So then in our little breakdown up here, then we know we can go ahead and plug in 0 for M. And it also means that 0 times B is still 0. So that means that this number is just A times N. So if A times B is 6 and A times N is 3, what common factor do 6 and 3 have in common? Well, they both got a 3. So you can say that this is 3 times 2, and this is 3 times 1. So that means A is 3.
He asked me to go live with him. He said he would take care of me. That way we could spend more time together.
Actually, I would have to go over here. 3. B is 2. And N is 1. So when we factor it, it factors into 2x plus 1 times 3x plus 0. So our solutions are from solving these two smaller linear equations. And 3x plus 0. Yes, we can. So what we said about linear equations is they are always solved by negative this thing divided by this thing. So that means that this is x equals negative 1 over 2. This one, negative 0 over 3. But we can simplify that, and that just becomes 0. Okay? So this is one of the reasons factoring is such a big deal. Is it's actually kind of the most common and simple way to solve quadratic equations. And if you go into cubic equations, or you keep going up, then you will get into this, like you'll find that that's usually the place to start, is if you can factor that equation into preferably a bunch of linear equations, but into smaller groups of equations. Those smaller ones are easier to solve, and this is how we, like I said, this is how we go about solving most of these. So let's do another one. So how about x squared minus 144? Okay. So again, you can do the long drawn out way, and it's all about what works for you. A in this case is 1, because it's 1 x squared. We just don't write the 1 because it's kind of always there. B is the number in front of x. So in this case, it is 0, because there aren't any just x's. There's an x squared, but there isn't an x. And C is negative 144. Okay. So again, draw our little thing. So in general, if one of the things is 0, that's if A, B, or C is 0, that's a big tell that something interesting is going on there. In this case, B is 0. We'll get to what that shows in a second. Let's go through our normal thing. So capital A is going to be the number that's here times the number that is here. Well, something times something else equals 1. For the most part, in these kinds of equations, that means the only factors of 1 are 1 and 1. So we can kind of put that 1 there. Now the factors of 144 are a little bit more involved. 144, 2, and 72, 3. Oh, I keep doing it. And 48, I think. And they really keep going. 4 and 36. 6 and 24. So you have all of these different things. But this 0 is where the, I'll draw a dot, 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 because there are actually more. This is where this comes into play. This means that this is 1 times n plus 1 times m. Because these are 1 and 1, so an plus bm becomes just n plus m. And if you see this, something plus something else equals 0, then you know something about these two numbers. Whatever they are, they have to be equal and opposite. So n equals negative n. So what this means is that this thing down here, the two factors that you choose, can't be 1 and 144, because that is not equal to that. So the actual two factors you use are 12, 12. But one of them is negative. So x plus 12 and x, you could say minus 12 or plus negative 12. So x plus 12 equals 0 and x minus 12 equals 0. Well, then the solutions are x equals negative 12 and x equals positive 12. And this is a difference of squares thing that we, again, it's one of those special cases. But if you do it the long way, if you get good and quick with that, it works every time. Let's see. So again, it works the same way, and it's nice, neat, and easy. This process will work for most of the ones in this class, just because that's how we've set it up. We give you problems that are kind of doable with things like this, or at least easily doable. You won't really see, you know, any of these that are like decimals or weird fractions. But this is one of the more common ways of solving these quadratic equations. However, this is not always the case. I'm going to bring up a common enough thing that is very, very helpful, especially the higher you go. I find myself using this a good bit. But you can't always just neatly, easily factor problems. So let's take this one. x squared plus 2x minus 6. Okay. So let's take this one. So right out the gate, we see that this is a is 1. So that generally means that we're going to have a and little b be 1. So this could be x plus something times x plus something else. And now we need two numbers that add together to give you 2 and multiply together to give you -6. So 2 equals n plus n. -6 equals m times n. Well, if we look at the nice, neat factors of 6, you have 1 and 6, and you have 2 and 3. So, and because this is negative, that means when we add them, it's going to be one of them plus a negative of the other one. Well, we also know that this is positive, so that means that the bigger number here is going to be the positive one. Well, let's try 6 and -1. That's not 2. And 3 and -2. 1. I'm sorry, it's not 2. 5 is not 2. 1 is not 2. So that means that we can't really factor these. We come up with this other solution method called completing the square. Okay. So this is taken from an idea that we've had previously. It kind of takes where we came up with this idea of factoring, and we kind of turned it around. So let's assume that we had the answer, and we want to, so we had the thing that we're factoring it into, and we wanted to make this thing out of it. We could turn this into something that looks like this. X plus b squared plus some number a. The idea here is that for every possibility over here, we could pick two numbers here and here that would make you have that. We can fix the two numbers so that we will get whatever we want to at the end. So let's expand this and see what we get. So we said that it's going to equal 0. So this is x squared plus 2bx plus b squared plus a. So this thing is just, if we multiplied this out, we would just get this thing. Okay, so we haven't done anything special yet. Well, we said that you could take any numbers and you can pick them so that you get this thing at the end. Well, if we do the opposite and we say, okay, what two numbers do we have to have picked, A and B, to make it give us that, then we can just say, well, then we have this. So the best way to do that is to take this right here. Okay. because this is kind of a constant. It will always be there. So we figure out what b is. So it's everything in front of x. In this one is 2b. Well, everything in front of here is just 2. So that means that 2 equals 2b, or b equals 1. Now we have to figure out, what does a have to be over here? Well, now that we know that b equals 1, we know that this is x squared plus 2x plus 1 squared plus a. But like we said, whenever you have two equations, whether they're linear, quadratic, whatever, if they are set equal to each other, that means that their coefficients have to be equal. So the thing in front of the x here, I'm sorry, in front of the x squared here, has to equal the thing in front of the x squared up here. Well, they do, 1 and 1. The thing in front of the x here has to equal the thing in front of the x here. They do, 2 and 2. Well, that means that the thing being added here has to also equal the thing being added here. So in this case, we get -6 equals 1 plus a. A equals -7. So point being, we can take this thing and we turned it into this. So this is how we create it. I'll show you the more correct way of solving it, but this is where the idea comes from. So let's rewrite our problem. X squared plus 2x minus 6. We said that we are turning that into something of this form. So x plus 1 squared minus 7. And believe it or not, this is actually very easy to solve. So if you had x plus 1 squared minus 7 equals 0, you move the 7 over and you get x plus 1 squared equals 7. Now we can get this squared here to the other side. The way you do that is you square root. So when you take the square root of something, that gives you x plus 1 equals plus or minus square root of 7. And then you move the 1 to the other side. And you get x equals -1 plus or minus square root of 7. So these are two different answers because there's a plus or minus. That's what the symbol means. So one of them is x equals -1 plus square root 7. And then you have x equals -1 minus square root 7. So this is the answer, completing the square. The way we actually go about doing it is actually much more streamlined. So I'll show you that by doing a new problem real quick. So that was just me trying to figure out, okay, well, what can I do? But this is knowing what I know already. So we're going to complete the square. So what we do is we take half of this thing. So So take half, and that is -2. And add that squared to both sides. And also move this thing over. So I guess you could say do this first, and then that doesn't really matter. So what we get is x squared minus 4x equals 1. And then when we do the second part, we add -2 squared to both sides. So you get x squared minus 4x. -2 squared is +4. And by doing it this way, we know that this always scrunches down into x plus half of that thing that we took right there. And then 1 plus 4 is 5. Sorry, I forgot the square. So you take half of this one and square it, which in this case gives you 4, and add to both sides. So then we get x plus -2 equals plus or minus square root 5. And we get x equals 2 plus square root 5, or x equals 2 minus square root 5. Okay. So again, we're presented with a problem. We take half of this thing and square it, and then add it to both sides. And then we also move this number over here. So you move the number over first, add half of the middle one squared, and it factors down to that, and we get that and that. So this is the other way of kind of simply solving